All right, let's talk about one of the most powerful and, yeah, riskiest techniques for scaling your systems. This is the kind of hack that separates the startups that crash and burn from the ones that can actually handle massive, massive growth.
So let's set the scene. Your app is a huge success. Your web servers, they're scaling beautifully, handling millions of users without breaking a sweat. Everything seems perfect, except for this one giant, glowing red problem sitting right at the heart of your system, your master database.
Yeah, it's just hit 10 terabytes. The disk is completely full, the CPU is literally melting like cheese, and every single query is crawling to a halt. Your entire application is just seconds away from grinding to a complete stop. So, what's the move? I mean, the old solution was just to buy a bigger, badder, more expensive server. That's called vertical scaling, or scaling up. But you've hit the hardware limit. That path is officially dead. You need a new game plan. Okay, so you've basically got two fundamental paths you can take. Scaling up, that's what we just talked about, making one server more and more powerful. It's simple, sure, but it has hard limits and it creates a single point of failure. The other path, scaling out, is all about adding more servers. And this is where things get really interesting. Right, so we've got to scale out. And the ultimate hack for doing this with a monster database is a technique called sharding. You know, the core idea behind sharding is actually incredibly simple. You're just taking one massive, slow database and breaking it up into smaller, faster, much more manageable pieces. We call them shards. So instead of one giant monolith, you have a whole fleet of nimble little databases. But how do you decide which piece of data goes into which shard? Well, that's the job of the sharding key. This is just a column in your data, think user ID or maybe email, that some simple logic uses to route everything. And listen, this choice is without a doubt the single most important decision you are going to make in this whole process. Get it wrong and you're in for a world of pain. So let's walk through how this works. Imagine every user query is like a glowing orb of data. They all flow toward one single entry point, a little intelligent box we'll just call the router. And the router's job? Super straightforward. It just peeks inside each of those data orbs and looks for one specific thing, the user ID, which we've decided is our sharding key. And this is where you can see the simple genius of it. The router runs a really basic hash function, something like a modulo. So if the user ID is an even number, that data orb slides down a glowing blue tube to shard A. If it's odd, it zips down a glowing green tube to shard B. And just like that, you've perfectly split the load. It's elegant, it's simple, and it works. For a while. And this is where we hit a massive architectural landmine. I mean, a huge one. Because there's a massive, massive catch with our simple user ID sharding key. What happens if a celebrity, let's say Justin Bieber, signs up for your app? And what if all 50 million of his fans sign up right after him? And they all want to see his latest post at the exact same time. And that brings us to what engineers call the hotspot key problem, or maybe more famously, the celebrity problem. It's what happens when a ridiculous amount of traffic all gets directed at a single key, leading to this huge, dangerous imbalance in your system. So let's say Justin Bieber's user ID is an odd number. Well, according to our logic, all of his data and everything related to it gets assigned to shard B. Suddenly, 50 million fan requests all hammer shard B in the exact same second. Shard B catches fire and dies. Meanwhile, shard A is completely idle, cool as a cucumber, just sipping a drink, totally bored. Your system is now half dead and half useless. This is a catastrophic failure. So how in the world do experienced engineers dodge this bullet? Well, they use a much smarter routing strategy. Instead of a simple modulo function, the pros use a more advanced technique called consistent hashing. Now, we could do a whole explainer just on this topic, but the quick version is this. Consistent hashing maps both your servers and your data keys onto a sort of virtual ring. This helps spread the data out way more evenly, and it makes it much easier to add or remove servers without having to reshuffle everything. It's a huge help in mitigating, though maybe not totally eliminating, that dreaded hotspot problem. But even with these clever solutions like consistent hashing, it is so important to remember that sharding is not a free lunch. It comes with some really serious hidden costs. First off, resharding. What do you do when one of your shards gets full? Moving all that data around without downtime is a total nightmare.
The celebrity problem, as we saw, can still pop up. And what about database joins? Ugh, man, trying to perform a join across multiple independent servers is incredibly complex and slow. This often forces you into duplicating data, something called denormalization, just to make basic queries even possible.
So here's the bottom line, right? Sharding gives you what feels like infinite space and scalability, which is amazing, but it comes at a steep price. It makes your entire system an order of magnitude more complex. It's a trade-off, and you have to be ready to pay that complexity tax.
So sharding is a powerful tool for scalability, but that's just one piece of the puzzle. Tomorrow, we're going to step back and look at the 3 foundational pillars of any good system design: reliability, scalability, and maintainability. Hope to see you then.